All right, so here we are, and we found the midpoint minus the mean times, squared times the frequency. What a pain. We dragged it down the column, and then I went and found the sum of that column. Now, why am I doing that? Well, because that's part of the formula for standard deviation. If you look at the formula for standard deviation, it says you take the midpoint, or the value, if you will, minus the mean. Here it is. And then you square them, and then you add them all up, right? And then you divide by how many of them there were, if it's for a population, and how many there were minus 1 if it's for a sample. So, hold on, let me zoom back down. Too far? I've gone too far. There we are. Okay, so here we are. So I found the sum, I added them all up. Now I'm going to find the variance. Now the variance, this is a sample, right? Old Faithful's erupted a lot of times. So what I'm going to do is I'm going to take that sum that I just found, which is this column right here, the sum of that column, and then I'm going to divide it by the sum of the frequencies minus 1, i.e. n minus 1. Because this cell right here is C9, that's n. That's the sum of this column, take away 1. That is now the sample variance. Sample variance. Because we're working with a sample here, so you've got to know in your head that's the one you need. All right, now what about the standard deviation? Sample standard deviation. Well, remember, that's equal to the square root of that number. There we go. Now I know what you're thinking, Alana, isn't there an easier way? Not that I know of. Not for group data. You're stuck doing this. The hardest formula in the whole thing is this one right here, where you take the midpoint minus the mean, give the mean dollar signs, mean down here, close your parentheses, square it, and times it by the frequency right there. And then you drag it down the column. All right, we found the sample variance and the sample standard deviation. Let me copy and paste, oops, those back in here. Now, they're only approximate because we used midpoints instead of the actual values. That's what makes them approximate. So that's as good as we can get. Now, we're going to interpret the mean. We expect to wait about 74.85 minutes, give or take 14.72 minutes between eruptions at Old Faithful. And there we go. That give or take, right? That's how standard deviation and mean get interpreted together. All right, what do you notice about the distribution that should be mentioned if you were going to discuss the average? All right, so if you look at this a little bit, matter of fact, let me go make a picture of it. Go back to Excel, make a frequency, insert. It's a histogram, right? Because this is quantitative data that we're looking at here, not qualitative. There are my labels right there. Okay, make this disappear. I'll make that disappear for right now, and I'm going to make it so that, there we go. All right, so this distribution is skewed left a bit because it's got kind of a tail over here. It's also kind of bimodal. It's got a peak here at the low end and then another peak up here. Right, see that? Got a hump and then another hump. Most of them are between 80 to 89, but it's definitely skewed left, which brings into question the whole using the mean in the first place. So it's skewed left. So perhaps mean should not be used to discuss the average time between eruptions. Also, I suppose that doesn't deserve a parentheses. And then also, the data has two big clumps. One around the 50 to 59 minute mark, and one from 80 to 89. So it looks like you're mostly going to be waiting either this time or this time. All right, we're all done with 3.3. I'll meet you back here for 3.4.